Welcome to tonight's video on Unit 3, Part 4, talking about probability. There's some terms that you want to know about probability. First of all, experiment. An experiment is anything that we're going to take the probability of, basically any event for which the result is uncertain. Outcomes, those are the possible results of the experiment. Sample space, that's the set of all possible outcomes of the experiment. That's going to be your sample space. And the event is a sub-collection of the sample space. And in this case, the event is what outcome we want when we're finding the probability. So first of all, we're going to list some sample spaces. So the sample space, if you toss one coin, that would be heads or tails, right? That's the sample space. If you toss two coins, the sample space would be that you could get heads, 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 tails, tails, heads, tails, tails. And then the third one, if you toss three coins, now you could get heads, 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 tails, heads, tails, tails. We could get tails, or sorry, heads, tails, heads. We could get tails, heads, tails, 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 heads. We could get tails, heads, heads. And last we could get tails, tails, tails. So there are 8 outcomes for 3 coins. Here's some examples. Find the sample space for a letter chosen at random from the first half of the alphabet. Well, there's 26 letters in the alphabet, so half of that would be 13. So you have to list the first 13 letters of the alphabet, and that would be basically all the letters up to M. All right, then sample space for a 6-sided die. That's 1, 2, 3, 4, 5, 6. Sample space for a coin that is flipped once and a 6-sided die is tossed once. So the coin is flipped once and the dice, so you have heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, and then you can do the same thing with tails. Tails 1, tails 2, tails 3, tails 4, tails 5, tails 6. All right, so finding probability. So you take and you toss 2 coins. What is the probability that both land heads up? Well, the event that we want is that they both land heads up. So heads, heads. So there's one way that this happens. The sample space, remember there are 4 objects. It's heads, 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 tails, 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 heads. So there's 4 in there. So the probability of what we want of it landing heads up is 1/4. Right, so the next one, you draw 1 card at random from a standard deck of 52 playing cards. What is the probability that is an ace? Remember, there's 4 aces in a deck. There's 52 cards. So it's 4 out of 52, which reduces to 1/13. So the probability of an event, remember, it's the likely outcomes, the outcomes that we want, over the sample space, the total outcomes. So if you toss 3 coins, what is the probability that all 3 will land tails up? So you get tails, tails, tails. Well, there's only one way for that to happen. But remember, when you toss 3 coins, as we talked about up here, there are 8 possible outcomes in the sample space. So therefore, the probability is 1/8. Whenever two coins are tossed, what is the probability that you get heads and then tails? So basically, for the event, right, the number of ways the event, remember you want either heads, tails, or tails, heads, right? So there's two of those. The sample space, remember when two coins are tossed, the sample space, there are 4 outcomes. So the probability of the event is 2/4, which reduces to 1/2. You draw one card at random from a standard deck of 52 playing cards. What is the probability it's a diamond? Well, the number of diamonds in the deck is 13. The number of cards in the sample space is 52. So the probability of the event is 13 out of 52, which is 1/4. You toss 2 6-sided dice. What is the probability that the total of the 2 dice is 7? Well, if you notice the number of ways to get a 7, if you list that, it could be 1/6, or it could be 6/1. It could be 3/4, 4/3, 2/5, 5/2. So basically there are 6 ways for that to happen. The sample space, well, if you have 6 outcomes on one die and 6 outcomes on the other, that's 36 total outcomes. So the probability of the event would be 6/36, which is 1/6. So now looking at this figure here, we can find some probabilities. The figure shows the number of degree-granting post-secondary institutions in various regions of the United States in 2015. What is the probability that an institution selected at random is in one of the 3 southern regions? Well, if you notice, the number of post-secondary institutions in the southern region, in the 3 southern regions, right? The 3 southern regions are South Atlantic, East South Central, and West South Central. So if you add those all up, 451 plus 302 plus 858, you get 1,611. And the total number of colleges, if you add up all of these here, is 4,322, sorry. Is that right? So then the probability of this happening, 1,611 over 4,322. If you're talking about the Pacific region, well, the Pacific region, the number of ways, there's 640 institutions there. And the sample space, remember, is 4,322. So the probability of that event happening is 640 over 4,322, which reduces to 320 over 2,161. All right, in Pennsylvania's Cash 5 game, a player chooses 5 different numbers, 1 through 43. If these 5 numbers match the 5 numbers drawn in any order, the player wins or shares the top prize. What is the probability of winning the top prize when the player buys 1 ticket? So the number of ways that you can win, well, the only way you can win is matching the 5 numbers drawn, so that's 1 way. The number in the sample space, well, if you have 43 numbers to choose from, and you're choosing 5, it doesn't matter what order those 5 numbers are drawn, just that those 5 numbers match your 5 numbers. So 43 choose 5 or 43 combination 5 is 962,598. So the probability of this person winning the Pennsylvania Cash 5 game is 1 in 962,598. All right, so mutually exclusive events. These are two events from the same sample space when they have no outcomes in common. So they're mutually exclusive if you take two events and they don't share anything. But there is something called the union of those two. So if they're mutually exclusive, you just add the probabilities. But if they do share something, they're not mutually exclusive, then you have to subtract the probability of them both happening. And we'll get to that. So for example, one card is selected from a standard deck of 52 playing cards. What is the probability that the card is either a club or a 10? So the probability of getting a club or probability of getting a 10 equals the probability of getting a club plus the probability of getting a 10. Now, is there overlap? Yes, there is the 10 of clubs. So you have to think about what's the probability of drawing just the 10 of clubs. So the probability of getting a club, well, there's 13 clubs and there's 52 cards. Probability of getting a 10, well, there's 4 10s in the deck and there's 52 cards. Minus the 10 of clubs, well, there's one of those in the deck and there's 52. So 13 plus 4 is 17, minus 1 is 16 over 52, which reduces to 4 out of 13. So that's an example where they're not mutually exclusive because the 10 and clubs, they share a card. So they're not mutually exclusive. However, example 2, the probability you roll 2 6-sided dice, the probability that the die you roll is the sum to 6 or 9. So probability the sum of 6 or probability sum of 9. So that's going to equal the probability that you can roll a sum of 6 plus the probability that you roll a sum of 9. And there's no overlap. So therefore you just add those two. So they are mutually exclusive. So probability of getting a 6, remember we did that earlier. Actually we didn't, we did 7. So for 6, you can have 1 5, you can have 5 1, you can have 2 4, 4 2, and 3 3. So there's 5 ways to roll a 6. So 5 out of 36. For a 9, you can have 3 6, 6 3, 4 5, 5 4. So there's only 4 ways to roll a 9. You add those up, you get 9 out of 36, which is 1/4. All right, so go ahead and try this next one on your own. I'll give you a couple minutes and then pause the video and then I'll go through the answer. All right, so welcome back. So if you look the one card drawn at random from a standard deck of 52 playing cards, what is the probability that the card is either an ace or a spade? So notice there is overlap, so you have to take the probability of getting an ace plus the probability of getting a spade and subtract the probability of getting the ace of spades, and you get 4 out of 13. All right, so Human Resources Department in this chart here, showing the number of years of service for each employee. The table shows the results. So what is the probability that an employee chosen at random has 4 or fewer years of service? So here is 4 or fewer years. Sorry, right here. So that would be 157. So the probability of this event would be 157. Now the sample space, when you add these all up, is 529. So there you go. So then it says, what is the probability that an employee chosen at random has 9 or fewer years of service? So 9 or fewer years means that you're going to take the top 2 here. So you're going to add these two. So now 157 plus 89 is 246 over 529. All right, for the last one, what is the probability that an employee chosen at random has 30 or more years of service? 30 or more. All right, 30 or more. So basically we're talking about from here down. So you have to add those. So the probability of that event happening is 66 when you add those up, 30 or more, plus, or sorry, over the total sample space, which is 529. All right. So that concludes our video here on probability. If you have any questions, please feel free to ask in class, and have a good evening.